Section 8.2.16. According to a study, the proportion of people who are satisfied with the way things are going in their lives is 0.75. Suppose that a random sample of 100 people is obtained when it completes parts A through E below. Now, suppose the random sample of 100 people is asked, are you satisfied with the way things are going in your life? Is the response to this question qualitative or quantitative? And then explain. Okay, well first, we know that the qualitative or categorical variables allow for classification of individuals based on some attributes or characteristic. Quantitative variables provide numerical measures of individuals. The values of quantitative variable can be added or subtracted and provide meaningful events. Now the response is qualitative because the responses can be classified based on the characteristic of being satisfied or not. For part B, it says explain why the sample proportion is a random variable and what is the source of variability. Okay, now we review how a sample proportion could be considered a random variable and what is causing this proportion to vary. We use this to explain why the sampling proportion varies and is a random variable. The sample proportion is a random variable because the value of the sample proportion varies from sample to sample. The variability is due to the fact that different people feel differently regarding their satisfaction. Okay, now part C, we want to describe the sampling proportion of P hat, the proportion of people who are satisfied with the way things are going in their life, and be sure to verify the model requirements. So, talking about the model requirements, we have to let P be the proportion of people who are satisfied with the way things are going in their lives, and we're going to let N be the size of the sample. Now, for a simple random sample of size N with independent sample values and a population proportion P, the shape of the sampling distribution is approximately normal, provided the sample size is no more than 5% of the population size, and N times P times 1 minus P is greater than or equal to 10. Okay, so what we want to do is we first want to determine what is the mean of the sample proportion. So the mean of the sample proportion is going to equal P, which in our problem is 0.75. Okay, so because this is the population of all the people, the sample size of 100 is going to be no more than 5% of the population size. So now what we can do is we can now figure out if N times P times 1 minus P is going to be greater than or equal to 10. We need to check that requirement. So we know that the sample size in our problem, okay, we know N is equal to 100, and we know that P is equal to 0.75. So we have 100 times 0.75 times 1 minus 0.75, and we want to see if that's greater than or equal to 10. So if we take that value, then we see that we end up multiplying them all out. We end up getting 18.750, and that is greater than 10. So that checks. So now what we can do is we can now determine what is the standard deviation of the proportion sample. So let's recall that the formula for that is equal to P times 1 minus P divided by N. So we know that P is 0.75. We're going to multiply that by 1 minus 0.75. And we're going to divide that by the sample size of 100. So if we round this to 3 decimal places, then we get the standard deviation of the sample proportion to be 0.043. And so therefore, we can say since the sample size is no more than 5% of the population size, and the fact that we got the value in part 2 to be greater than or equal to 10, the distribution of the sample proportion is approximately normal, with the mean of the sampling proportion to be 0.75 and the standard deviation of the sampling proportion to be 0.43. Excuse me. Okay, now let's look at part D. In part D it says, in the sample obtained in part A, what is the probability that the proportion who are satisfied with the way things are going in their life exceeds 0.78? So what we're doing here is we have a proportion now, okay, and we're going to call this sampling proportion P subscript 1, and that's going to equal now 0.78. And so what we want to be able to do is we want to be able to find the probability that the sampling proportion is going to be greater than that 0.78. So recall that what we want to do is we're going to draw a picture, okay, and that is of the bell curve. Okay, we know that our mean is 0.75. Okay, and what we want to do is we want to find the area that is to the right of 0.78. Okay, so we can use technology. We can use either StatCrunch and the calculator, so we're going to do both. Okay, so what do we know? We're going to find normal CDF. We know that our lower bound is 0.78. We know that our upper bound is going to be 9999. We know that our mean is 0.75. And then we got our standard deviation to be 0.043. Okay, so let's go ahead and put that in our calculator. So we have second distribution. We're going to go to normal CDF. Our lower bound is 0.78. Our upper bound is 9999. We have our mean at 0.75. And we have our standard deviation at 0.043. Okay, so therefore, if we round that to 4 decimal places, we will see that we get 0.2427. Now, if we wanted to do this on StatCrunch, we know that our mean is 0.75. We know that our standard deviation is 0.043. And we want to make sure it's going to be greater than 0.78. So therefore, we're going to get the same area as we did on our calculator. Okay. And so, therefore, we would say that the probability that the proportion who are satisfied with the way things are going in their life that exceeds 0.78 is 0.2427. Okay, now let's take a look at part E. And part E is saying that using the distribution from part C, would it be unusual for a survey of 100 people to reveal that 68 or fewer people in this sample are satisfied with their lives? Okay, so what we're doing here is now we have 68 or fewer. Okay, so in this case here, if it's 68 or fewer, we're not given a proportion. So we are given a new proportion, P2, and that means that we want to find 68 out of the 100 of the sample. Okay, and so recall that that formula is x, and in this case we're looking at x2 divided by n, since that's the second x that we're dealing with, and 68 divided by 100 is 0.68. So now we're looking at that. So now what we want to do is, it says that we want to find 68 or fewer people. Okay, so if we're looking for 68 or fewer people, then that means that we're looking for the probability of where the proportion is going to be less than or equal to 0.68. So if we were looking at the bell curve, and we know that our mean again is 0.75, and we're looking at the area that's going to be less than 0.68. And that's going to give us the probability. So therefore, what we want to find is normal CDF. We know that our lower bound is going to be negative 9999. Our upper bound is going to be 0.68. Our mean is 0.75. And our standard deviation is 0.043. So let's go ahead and use our calculator to find that. So we have second distribution. We know that our lower bound is negative 9999. Our upper bound is 0.68. And then our mean is 0.75. And our standard deviation is 0.043. So therefore, there is our probability. So if we round that to 4 decimal places, we get 0.0518. And if we wanted to do this on StatCrunch, we know that our mean and our standard deviation is remaining the same. And we know that this has to be less than 0.68. And if we compute, then we're going to get the same area. For our result. So therefore, we can conclude and say that the probability that 68 or fewer people in the sample are satisfied is 0.0518, which is unusual because this probability is less than 5%. Okay, now we didn't convert them to z-scores in this example. Now, my math lab is going to take whether we convert them to z-scores or we leave them as the value itself. So keep in mind that we need to know how to do both.